All right, so in order to do this question, we're going to have to set up our Venn diagram, which we've seen previously. And now we're going to look at two complements, A complement, B complement, and then we want to find their intersection. So let's set up our Venn diagram just like we did last time using a little bit of movie magic. All right, so we know that A, B, and C are going to overlap a little bit. So we can see that A, B, and C each have a 3 in it, kind of what we saw last time. So they each have a 3. I'm going to cross that out and I'm going to write it right in the center. So that centermost kind of curvy triangle area, that represents all elements that are part of A and B and C. And I think from last time we saw that 3 is the only one that has this quality. So let's head over to A and let's just kind of pick it apart piece by piece. So A has 1 in it, B has 1 in it, C does not. So 1 is going to belong to A and B, but it's not going to belong to C. So it's going to go right here. So again, this says, hey, I'm in A. Notice it falls in the A circle. Hey, I'm in B2, falls in the B circle, but it's outside of the C circle, which is good because it's only in A and B. So, okay, so 1 is taken care of. And then how about 5? So 5 is in A, but it's not in B and it's also not in C. It's only in A. So it's just going to be out here. And then for 7, I see that 7 is in A, not in B, but also in C though. So I just want to be A, C, but not B. So again, I'm going to put it out here. If it was over here, that would be inside B also. We don't want that. We just want A and C. So we want to be on this side of the B border. All right, so A is all set. Let's go back to B. B has 2 in it. And it looks like B is the only set that has a 2 in it. So 2 needs to go over here. And then as for 4, I see that 4 also belongs to C. So it's going to go in that B overlap C section. And then C has 6, 7, and 9. So 6 is, I mean, we kind of already can tell because A and B, we've already taken care of all of them. So we know that 6, 7, 9. Oh, sorry, I forgot to cross off my 7. Hello. So we know that 6 and 9 are going to go right here. So now that we have everything taken care of, so 1, 3, 5, 7 for A, 1, 2, 3, 4 for B, 3, 4, 6, 7, 9 for C. So I'm looking good. And then we have the universal set, right? Which is this rectangular region. It's our backdrop, it's our universe, whatever. It has numbers 1 through 10. So we already have 1, 2, 3, 4, 5, 6, 7. So I don't have an 8. So 8 must live outside of ABC. And then I have a 9 here. And so I'm just missing 10. So 10 has to live outside of ABC. So this is the complete Venn diagram for the given sets ABC with universal U. So before we go into A complement, B complement in this specific example, what I really want to do is I just want to look at the structured A complement and B complement. So without rewriting the whole thing, just looking at the setup spatially. So it's the same Venn diagram, just no numbers. So for A complement, we know that A complement is going to be everything outside of A. So if I were to shade that, this is what A complement looks like. I'm just avoiding A altogether, and that's going to give me A complement. Right, so I don't care that I'm going into B at all or into C or whatever. I'm staying inside my universe and I'm just avoiding A. So notice that the negative space, the blank space is just A. So this junk right here, this represents A complement. And let's do the same thing for B also. So if I want to find B complement, then what I'm going to do is I'm just going to highlight everywhere outside of B. So if I do like this, just making sure to miss B altogether. Right, and so you can see everywhere that's not blue, that's going to be where the set B is. Hence, all the blue shaded region, that's now B complement, everything outside of B. So if I want to find A complement, intersect, B complement, what I want to do is I want to figure out where do I have this like pink shading and where do I have the blue shading? I need both of them. To be the intersection, I need both shadings. So I'm going to use my gray highlighter and I'm just going to shade everywhere that has both. Right, so here. Right, so if, for example, if I were to shade right here, that's not correct because it only has the pink highlighting. It doesn't also have the blue highlighting, so I'm not going to shade that part. Okay, so all of this is good, great. Notice if I were to shade right here, that's incorrect because it only has blue. It doesn't have pink, it doesn't have both. So I'm going to avoid that guy. And so what you'll see is that when we're done shading everywhere that has pink and blue, we're just actually outside of A and outside of B, which should feel right because the intersection symbol to you should say and. This is not A and not B. Right? I want you to think that when you see this notation, A complement, intersect, B complement. So complement means not. So A complement is not A. This cap, this upside down U, is intersection and it means and. So not A and not B. So now look at our picture, yeah? I'm not in A and I'm not in B. Haha, this is A complement, intersect, B complement. So if I bring it back to our super duper Venn diagram and I highlight in gray, let's see what we end up with. All right, so I've taken the shading that we did with the pink and the blue crosshatch, and I've transferred it over to our super duper numbers and such Venn diagram. So now what I'm going to do is I'm just going to say, okay, what numbers did I cover up in gray? Right, so this is A complement. Intersect B complement, it's just the numbers that got hit with the gray. So it's going to be 6, it's a set, so we'll use curly brackets, 6, 8, 9, and 10. So when you're writing sets and you can order the elements, you know, these are numbers. So this has a nice quantitative, easy to order, low to high flow. So I want to write 6, 8, 9, 10. So if you wrote 6, 9, 10, 8, I mean, technically not incorrect, but when you enter it into the homework system, you'll notice that it would ding you. So you just want to make sure that you write it low to high. So bing, bing, bing. That's it.